Good morning, everyone. This is Andrew Parnell from Early Bird Software, here to talk to you again about how some data science concepts can help you run your business. Today, we're going to talk about linear regression or basic regression modeling, something that you may remember from high school or college stat courses, but still to this day, a lot of businesses are not using to help understand how their business is running. We're going to talk about what that is at its basic concept, and then run through a couple examples of how you can actually use this to make decisions in your business. So let's talk about what basic regression modeling is at its very basic state. Really, all it is taking a collection of data, plotting it simple x versus y, and then finding a best fit relationship between those two data points. So, as a simple example, let's say that you are a manager or an owner of a grocery chain. And what you want to know is, what will my profit be based on the number of people that are in my store? Now, of course, the more people that are in the store, the higher your profit's going to be. That's sort of a given. But we want to know by how much and what that actual number is. So you plot those points, everything from all of last year's data. This day I had this many people in the store, and this was my profit at the end of the day. You plot all of those data points on a scatter plot, you run the model, it gives you a best fit line, and then you can actually use that line to predict out, based on how many people are going to be in my store on a given day, what should my expected profit be on that day. You can use that predict into the future and look at what that is. Now, there's two cool things about the way this is done. One, with technology these days, you don't have to do this manually. That's what's so great about this. The system can just do it. It plugs into your database, plugs right into your transaction system, and can feed you this information back. The days are over when you need to download this data into a spreadsheet, into Excel, and play around with these models. Don't waste your time with any of that. This can all be done automatically and feed you a report of what the expected profit is in this example. The other cool thing about the way this works is that it builds on itself. The more data you get, it adjusts and gets more accurate. So let's say, for example, we did this for all of the data we had in 2017, and we wanted to predict out 2018 profits. We run that first, and then as of January 1st, we have an accurate prediction of what the 2018 profit might be. But then, as we go forward and as it feeds in January's data, well, now the model's going to adjust itself because it has more data to look at and can adapt that for the rest of the 2018 model, and thus for February, and thus for March. So it's sort of live building on itself, and the more data you get, the more accurate the model is, and the more accurate your profit predictions are going to be. Other ways you can use this information is to also compare, obviously do forecasts of what your profit and spending might be, but then you can also compare it for performance. So maybe you have 10 grocery chain locations, you run this model for each individual location, you can actually see which ones might need help, who's hitting their numbers, who's exceeding the numbers, and who might need help because they're not hitting the average profit for the number of people they're getting, the number of traffic they're getting. Okay. Now, the other interesting thing about this is that it's not always as simple as a basic linear regression. You can actually build on this and make these models a little more complicated. So you can add complexity and you can add variables to answer more difficult business problems. So let's take this intermediate example, a second one. Same grocery chain model, but this time we want to know what hours of the day should we set our hours to be to stay open based on the traffic. So we've already run this model on what our expected profit is based on the traffic in the store. And now we know the overhead of what our overhead costs are basically on keeping the store an extra hour open. So we can compare those two models against each other and run a new model that says, based on the traffic that's coming in at 5 a.m., 6 a.m., 7 a.m. versus the expected profit of that, and then compare that against the overhead incremental cost of keeping the store open, we can actually get a model that gives us the relative value of keeping our store open for an additional hour. So we can use that at our retail store or at our grocery store to tell us, here's when you're going to make the profit, here's when you're actually going to be losing money on an hour, and you can actually understand when you should keep your store open and for what hours. So pretty useful information. Lastly, I want to talk through maybe a more complex example. So using the same grocery store, we want to solve a more complicated problem using this system and using these regression models. So let's say, for example, that you have a supply and demand model. You know that based on the price that you charge for this bushel of apples or this banana, you understand what the demand is going to be and how many you're going to sell based on this price. You raise the price, the less bananas you're going to sell. You lower the price, the more bananas you're going to sell. You have that model built out. You understand what that looks like. Well, but there's something interesting about food, which is spoilage. So your bananas are going to sell at a certain rate, they're going to be good, but then after a certain point, your bananas aren't going to be good anymore. They're going to spoil, they have a certain shelf life, and then your sales are going to plummet because you're not going to sell spoiled bananas, so you're going to have a lot of waste of your inventory and a lot of waste of your spoilage of your spoiled bananas. So this is one of the more complex models. What you can actually do is compare those two things against each other and have the system run a model that says, here, graph out the spoilage of how long it's going to take for this banana to spoil, and then run my supply and demand curve against that to tell me how early or what day should I start putting these bananas on sale before they spoil, so that I can spike demand and actually sell more of my bananas before they spoil, so that I lower the waste of not selling anymore once they spoil. So we can actually chart out this plot that says you should not put your bananas on sale. You should charge them at this price when they're fresh, and then at each subsequent day, your price can fluctuate based on how close they're getting to spoiling, and try to spike that so that you're not left with a bunch of wasted inventory at the end that you can't make any money on. You're selling the most, you're maximizing the profit and maximizing the amount of bananas you're selling based on the spoilage. And again, the great part about this model is you plug this in with the data, you don't have to do any manual effort. You're not downloading this information onto a spreadsheet and running charts. The system's running this for you and generating a report. You can even have this export out that says, based on every single day, go into the morning, here's what your bananas should be priced at. Here's what this product should be priced at based on the shelf life, based on the sales, based on the expected traffic, based on the weather. All of these factors can go in to spit out a report for you that can help you understand what your dynamic pricing model should be to maximize profit and maximize sales. Hopefully that makes sense. If you have any other questions or thoughts about how modeling, basic modeling or complex modeling can help solve some of your business problems, let me know. I'd be interested in hearing about it, and I look forward to talking to you again soon. Have a great one.